All right. For this week's sprint, first of all, I got myself an iterator working. This is the collection class that the iterator operates on here. The cell collection. Um, Basically, the only thing it does is it holds the min xy, max xy um, values that are got from the terrain object. And creates an iterator, or allows access to the begin and end iterators. The iterator itself, while I'm not sure it would be 100% STL compatible, does work as well as I need it to. It's got the equivalent, uh, not equivalent, the operators that are needed here. And basically the only thing is it does is it increments through internally on a 0 to what is it? 0 to end scale. Oh no, it just increments up. Um, and then calls the collection when it's wanting to be decremented. So the collection here checks for the ij value and gets it from the terrain object because the cell collection and the terrain object are friended together. So that leaves the add cells under method here, the one that's publicly open to the engine, um, will return a cell collection at the end of it, which is used in the collision test command just to, get the collection and then iterate through based on that rather than iterating through based on the list that was being created all the time. So the add cells under method is called every frame, just as it was earlier, but the only thing that gets done is we figure out the min and max coordinates of the box and then send a collection. Much more efficient that way. So let's see. Oh no, no mirrors, please. Okay, so the next thing up is I started working on getting the triangles issues dealt with and getting the point projected onto the terrain and getting normals put together. What I managed to do is getting the normal does work like it should. Where's that method? Right here. I've got a couple visualizer tricks in here, but the get triangle normal does work. I can show you that right now. As you can see here, we've got a normal for each of these triangles that are being highlighted. And if I move on to a slanted one, it's obviously a different normal depending on the triangle itself. What does not entirely work yet is part of the way there is the projecting onto the terrain. So what I have now is a system that identifies what triangle we're in, and obviously, as you saw, prints like visualizer draws the normal of that triangle, but I haven't gotten the math fully sorted out for actually projecting the point onto the surface. This, what I have right now, is close, but it only actually works for those completely flat terrain cells. Once I get onto the slanted ones, the point disappears below the surface and is affected by the height off, like whether I raise or lower the plane, affects where that bottom value is, and I haven't figured out exactly what's wrong yet. Obviously, my math doesn't work perfectly for when the normal and the straight down ray are not the same. I think it probably has something to do with how I'm calculating this clamped position's Y, but I haven't got it figured out, and I need to be on a plane at like 9:40 from Midway tomorrow, so I can't stay up much later to try and figure it out if I want to get to my plane on time. The other thing that I've got done is, oh geez, I have to pull it up again now, don't I? I have done some revising of the behavior tree project. It's a little hard on the eyes right now because I turned on edit mode. But basically, what it boils down to is I have changed the end goal that I'm trying to get to. I think that getting a full nav mesh, flood fill algorithm put together and the various goals needed for any object to work with that nav graph is a little ambitious. So at this point, I'm just going for a stationary turret that waits until the player is within a certain radius and shoots at the player. So then obviously there's changes to the nodes based on that. The other thing is I have done on paper and now I have written out on this document um, the actual internal components needed. Obviously not in a lot of detail yet, but I think for the most part, it's going to be pretty similar to what we already have, a game object component, a manager for those components. The biggest thing is going to be the internal behavior tree here, the actual structure that saves goals that the player loads in and processes them through. I'm going to be basing that, like I've said throughout this process, a lot on the work that we did in the Game AI class, but I do have to review over that, make sure I know the ins and outs of how that was working and how I can put it into my system. Like I said, didn't get a chance to actually put it into code yet, but a lot of the base features are there already. Once I can figure out this math stuff, I'm going to get right down to it. That's all I've got for today.